Good morning. In this part, we'll show how to adjust the airflow performance in the IZZI recuperator. Today, we're going to talk about the entire process of starting up the IZZI recuperator. That is, from taking the recuperator out of the box, hanging or installing it in the designated spot, to connecting it to the power supply and properly hooking up the standard control panel. What comes next? So, at the moment when we actually turn on the device, that is, we press start, at that point the fans start running. And now, depending on whether our heat recovery unit is equipped with a constant flow module, that is, already installed in the ventilation unit and connected to the control board, the entire process of starting up and adjusting the system involves entering the menu, going to peripheral devices, activating the module, turning on its test mode, and at that point, the device checks what maximum supply and exhaust airflow it is able to achieve. Okay, the heat recovery unit measured that we can set a maximum airflow of 270 cubic meters per hour. That's the maximum output, the maximum flow rate. Why? Because right now we have a simulated installation here, and on the supply side we have resistance at the level of 140 pascals, while on the exhaust side we have resistance at the level of 8 pascals. We can check these flow values right here. It's best to do this at points like the intake or exhaust grill, because that's where we have the full airflow passing through the device. Here, we actually don't have an intake or exhaust. We just have a simulated supply, where the measurement value on the anemometer is about 300 meters. The second measurement can be taken behind the second fan, or behind the exhaust fan. And here we have a measured value of 250 to 260 meters. And the device gave us a measurement of 270 meters. It should be taken into account that the measurement error when using an anemometer with a tube, where the tube creates additional resistance, is about 6 to 10%. So we're in the range of what the device measured for us. After leaving this measurement module, the value is displayed in cubic meters on the control panel display. And in the case where we don't have a constant flow module, this value is not shown to us in cubic meters here. We can also check, by clicking on the parameters, both temperature and flow, what the current operating mode of the device is. Alright, but that was the simpler version, where, after installing the constant flow module, the entire measurement process, in fact, the regulation of the fan output, was carried out automatically by the device itself. In such a case, our task is also to go through the building and check each supply point, meaning both supply and exhaust diffusers, that is, exhaust diffusers, and properly adjust the flows in the respective rooms. However, we will now show the procedure for how this should be done when we do not have a constant flow module. I'm going to turn it off here now. The value for cubic meters of air per hour has disappeared. So, what now? The first thing we need to do is definitely measure what flows we have, meaning the capacity in cubic meters on the supply side as well as on the exhaust side. So, starting from the supply side of things, we have a precise measurement of approximately 300 cubic meters as well, which is a significant volume. On the exhaust side, we have 260 to 270 cubic meters. So now we need to adjust the fans on the supply side so that it doesn't exceed those 270 cubic meters. Why? Because for the proper operation of the heat recovery unit, we want these two airflows to be as close to each other as possible to ensure proper air circulation throughout the building, but also to maximize the efficiency of heat recovery in the exchanger itself, since we can have three scenarios. The airflows are the same on both sides, or we can have more air being supplied into the building, which means we have what's called overpressure, where in this case, air escapes outside through every leak in the building. It can also go the other way, meaning we can have more air being extracted from the building, which creates underpressure in the building. So in this case, air is drawn inside through every leak. So the optimal working conditions are when these two airflows are the same. So now we need to adjust, correct the supply fan, reduce its output, its airflow, to achieve the same flows on both sides. So, following the instructions. In the standard control panel operation, we have a section called Program Performance Correction, where we can adjust both the supply and exhaust fans. In this case, we will adjust the supply fan so that the supply airflow reaches about 270 cubic meters, just like we have on the exhaust side. To do this, we go into the settings menu. Go back. Work mode parameter, work mode settings. And here we have supply fan correction, exhaust fan correction. So we enter the supply fan intensity correction. And here we can now adjust downward by percentage, meaning we can set the value by how many percent we want to decrease the fan's output or the airflow on the supply fan. Let's start with 10% and take a measurement. We need to get it down to 270 meters. Right now we still have 300, so let's correct by another 10%. We have 282, so if we add another 10% to that, we arrive at 260. Now, let's carefully examine what is present on the opposite side, specifically on the exhaust side of the component, to understand its characteristics and features in detail. $260. So you could say that right now we've balanced these two streams, meaning the amount of air on the supply and exhaust sides is the same. We can, the correction is active, confirm it, and exit the domain. But here, right now, 100%, we don't have the value in cubic meters. We only know it's 260 cubic meters. But what else can happen in such a case, when the system is already balanced? The same air flows on the supply and exhaust sides, but now we have usage, meaning the intake filter can get dirty. This will introduce additional resistance in the system, meaning really on the filter, which will again change the proportion between the supply and exhaust airflows. And once more we might have a situation related to negative pressure in the building, for example. So in such a case, you would again need to adjust the fans, or simply equip the device with a constant flow module, which will continuously correct the operation of the fans, taking into account the changing conditions in the system. So that's the procedure for a standard device equipped with a wall panel. And in a moment, we'll show you how it looks with a recuperator equipped with an app. That is, with the IZZI Connect recuperator. I also invite you to this section where we'll show how to install and start up the constant flow module, as well as, for example, the CO2 Hygro air quality measurement module. In the next part, I will discuss the installation of optional modules, such as the constant flow module or the air quality module for carbon dioxide and humidity in the IZZI recuperator.